Okay, welcome to Unit 3, Lesson 3, Properties of Parallelograms. We are now going to start talking specifically about one type of polygon, quadrilaterals, and we're going to go through the special types of quadrilaterals that there are. We're going to start off with parallelograms. Now, what you see here is a picture of a parallelogram. Maybe. It's not indicated it's a parallelogram. So what I want you to do is to pause the video and discuss with your group what needs to be shown on this picture to show that it is indeed a parallelogram. Okay? Well, what we need to do is to indicate that sides are parallel. It's a parallelogram, so you could guess from the name that there's going to be some parallel sides. And it has to be opposite sides. So we need to indicate that these opposite sides here are parallel. If we do that, that makes this a parallelogram. There we go. Now it's a parallelogram. Next, we're going to start talking about some actual properties that a parallelogram holds. We're going to talk about some theorems. What I'm first going to do is I'm going to move around the sides. And I want you to realize that as I move these sides, that these little pictures right here, they're not going to move. So I want you to watch the numbers. Here, let me just get rid of the pictures if I can. Little arrows. See if I can. There we go. Okay. I want you to pay attention to the side lengths. What happens to them? And please note that this is always a parallelogram, no matter how much I move it around. Let's try moving this. Okay, I want you to pause the video and make a conclusion with your group about what happens with the sides of a parallelogram. Okay. If you notice that no matter how much I move this around, what do you notice about the opposite sides? Right now, this is 3.55, and this is 3.55. This is 3.12, and this is 3.12. Let's move it back over here. Well, now this is 3.15, and that's 3.15, and these are also the same. And even if I move these sides around, still, they're the same. So what we can say is that opposite sides in a parallelogram are congruent. We know that their measures are equal. We can see that. So by seeing that their measures are equal, we know that they are congruent. Okay. Next, we're going to look at the angles. Now again, I'm going to move this around, and I want you to look at the angles and just kind of see what goes on. Okay, I want you to pause the video and discuss with your group what you saw and what conclusions you can make from that. Okay, now just like with the sides, if you noticed, what do you see the opposite angles always doing? They're always being congruent. They're always having the same measure. So we can say that in a parallelogram, opposite angles are congruent. Now again, I want you to look at the angles and try to make another conclusion. This time, don't think about the opposite angles. Think about consecutive angles. Think about the angles that are beside each other. What are these angles beside each other always? Okay, go ahead and pause the video and discuss with your group what you think happens. Okay. What I hope you notice is that if you add the sums of your consecutive angles, they always add up to 180 degrees, which means that they are supplementary. So in a parallelogram, consecutive angles, angles that are beside each other, are supplementary. And there's one last property that we are going to discuss, and it has to do with the diagonals. So let me find my diagonals and draw them in. Okay, and a diagonal is when you go from one vertex to the opposite vertex. It's where you draw a line through the polygon from a vertex to the opposite. Now I want you to look at the diagonals, and what do you notice about them as I move this around? Please note that these numbers represent from each vertex to the center. It's going from the vertex to the center. Okay, go ahead and pause the video and with your group discuss some of the conclusions you can make. Okay, what I hope you saw is that no matter how much I move this parallelogram around, our diagonals carry this property where this and this part of it are always going to be equal. Likewise, here and here. What our diagonals are doing is they are bisecting each other. They are intersecting right here at this point, and that intersection causes a bisection. And that is our parallelogram properties.